All right, this is just a quick video to demonstrate the PoBlocks code that I've written to take an analog input and convert it to a pulse width modulation output to drive the dim function on the UHF panel for the 7-segment displays. So you can see here on the left, dim input coming in on pin 41 is an analog input. Analog inputs are 12-bit D to A, or A to D rather, and that means it goes from a value of 0 to 4095. Right now the pot is set just about at mid-scale, and that's resulting in the values you're seeing. Now when we rescale that using the rescale block, that rescales that value from 0 to 4095 down to a 0 to a 100, which is our pulse width modulation duty cycles. Now, because the pulse width modulation output needs to be an inverted output, we actually are inverting that value by subtracting 100 and converting it to an absolute value. And so you can see the value coming out of that absolute function is a value of 48 for the duty cycle. Now that value is fed into the bright dim selector multiplexer, and that is controlled by an input from pin 1 on the Pokeys. If that value is 1, it's going to select input 2. The inputs are actually numbered from 0 on up. But when the value is a 0, as it is right now, then it's going to select the dim adjust output, which in this case is a duty cycle of 48. So that duty cycle of 48 is then fed to another select multiplexer, and that's controlled by this on-off input. Right now, it's actually input is in the on position, and that is selecting input 2. In other words, it's in on position, and because it's green, as you can see here, it is selecting input number 2. If it was a 0, in other words, the switch was off, it would be selecting 100. Now, the reason that it selects 100 is that 100, due to the inverted pulse width modulation, 100 is equivalent to the display's completely dimmed or off. All right, so let's take a look at what happens here graphically on the PoBlocks code. We've got monitor mode on. We're running the code in real time. Now I'm going to go over to the workbench and I'm going to vary the pot, and you're going to see these values go up and down. All right, so now you see that I'm turning the pot all the way one direction and all the way the other direction, and you can see the pulse width modulation values change as well as the analog input. All right, this is the pulse width modulation output from the Pokeys. We're displaying it on channel 1 on my oscilloscope here. And you can see as I adjust the potentiometer, like I did in the display on the Pokeys code window, that we're actually changing the pulse width modulation from one extreme to the other. That's considered 100% duty cycle, which would be display completely off, and that's the 0% duty cycle. Looks like we get a little residual spikes in there, but that's not going to matter, because keep in mind that what we're trying to adjust here is the dim setting, so that when we go from bright to dim on our displays, we've adjusted and balanced the light output on the UHF 7-segment displays to match any of the other indicators in our cockpit.